Good afternoon, everyone. Welcome to GlobeTech Medical Expo 2022 Pune. It's an exhibition on medical technology, hospital equipment, and healthcare solutions. I feel privileged to welcome you all on behalf of GlobeTech Medical Expo for the seminar on Convert any OT into Laminar HEPA OT with ductless system. We would like to introduce our guest speaker, CEO of Almed Equipments, Mr. Zakir Hussain. He has been working on infection control since last 15 years. Has been constantly tried to provide better system in the field of airborne infection control with success of more than 1,000 OTs all over India. He has vision to infection control, healthcare facility, OT on critical care area. I request our guest speaker to on the DSS, Mr. Zakir Hussain. Now I request Mr. Satish Mandole, Director of Global Tech Media Solution, to welcome to facilitate our guest speaker Zakir Hussain, CEO of Almed Equipments, Mumbai. Now I hand over the mic to Mr. Guest Speaker Zakir Hussain.
Good afternoon, everybody. Good afternoon, everybody.
Good afternoon, sir.
See, from last 10-12 years, I am working for infection control, and mainly the corona is also now the airborne infection control. Everyone is knowing about it. See, the air quality, how much importance of the air quality, now we people are understanding. Earlier, the people are not much concerned, or they are not much bothered about the infection. So whatever they are doing earlier, they are using the same technology what given in the pharma companies. Pharma company are using the clinical clean room. So the same system they are copied and they pasted to the hospitals, operation theatres. But the working environment of both the places is totally different. So they are in a pharma company, they have that much awareness that if I stop my AHU or the air flow is not maintained, then entire batch will get spoiled. Whether we are keeping that type of awareness or that type of precautions in maintaining the operation theatres. So we had come out with the solution where when the different situations are there, how to tackle those situations and what are the solutions for that. See, normally in our hospital, operation theatres are working only for the 6 hours, 8 hours maximum in a day. Then they are closed for the next day. They cannot keep the one patient after another patient and around means more than 6-8 hours, because then the air quality and the infection chances will get increased, and the air sterilization cannot be maintained for longer time, more than that. So we had come up with some good solution for that. See, let me tell you about the Almed equipment. We have all the certifications of the ISO 13485, ISO 9000, then the C certifications are there. And now we are taking the 14644, that is mainly for the air quality testing. I have the patent on this system. It's called the ductless air handling units. The patent is in my name. We have the ISO C certifications. Next. See, we had done the series of changes we had done. Earlier, ducted and ductless system. Why the difference? The system difference is there. I am telling you, because the duct is one of the major ground for the bacteria and fungus to grow. That is the one of the major hub to get the infections. Until unless you don't clear those means that big pocket of the infection, you cannot do the proper infection control. That I feel personally, because in a ducted system, as per the NABH also, they had given the two limitations. During the non-functioning hours also, you have to keep the A2 blow round the clock on. Maybe with temperature control. What you can do? You can do the temperature control. During the working hours, you keep the 21 degree. After the when there is non-functioning hours, you can keep around the 28, 29, whatever. So that the AC will not continuously on, or that load will means you will get the less electricity. One more, they have said that you can do the VFD. VFD means a variable fan device. What you can do in the non-functioning hours, you can fan speed, control the fan speed, so that the little bit air and means slowly 25%. If you keep 25%, that much flow will be maintained in the operation theatre. They said that you have to keep the continuously OT positively pressure. Means so air pressure, they said that the positive pressure is required continuously. That's why they are keeping it on. That's okay. In my system also, I had done the same technology can be possible. In my system also, I had given the small fan. See, now in their system, they are 3 to 5 ton blow has been given in their HU to maintain the flow. And for the non-functioning hours, to maintain that much flow, I had used one very small fan which will maintain that much flow, positive pressure in your OT. See, the earlier means next page. Whatever the problems are there in operation theatres, I had addressed each and every problems. In your system, when you compare with the operation theatres, when you plan to do the operation theatre, what are the problems to the doctors? Is that AHU has to be according to the NABH guideline. Then main problem is that the surgical site infections. How to tackle those surgical site infections? Normally doctors are giving heavy antibiotic after the surgery, which should not be given, because they have the fear of the surgical site infection. That's why they are giving heavy antibiotics. In a foreign country like America, after the surgery, they don't use any antibiotics to the patient, because once you have removed the problem, then antibiotics are not required. But in India, we are giving the heavy antibiotics after the surgery, because we have the fear always that the surgical site infection will be there and the patient complication will be there. Then when you go for the ducted system, maintenance cost is very high. Then medical legal problems is always there. Means you have the fear of the medical legal problems. Then you have to maintain the 20-year changes as per the NABH guideline. They said that 20-year changes has to be maintained in operation theatre. So how to maintain the 20-year changes? So it have to then you have to take the fresh air, then the 20% fresh air, 80% internal air. That type of circulation when you maintain, then you get the 20-year changes. If you don't take the fresh air from the outside, then the air changes cannot be possible. And OT cannot be positively pressurized until unless you don't take the fresh air from the outside. Okay. So that system is required. Normally, why I am telling all these things? Because people are using split AC or the cassette AC. This type of AC they are giving in operation theatres, and in that system the internal air only gets circulated. No fresh air is coming from the outside. So your OT is not positively pressurized. And why the positive pressure is required? See, if your OT is positively pressurized, the outside air will not come inside, and the dust particle and other things will not come in your OT. So your class can be maintained. So that's why you require the positive pressure system. Okay. So that problem is there. Say when you say the window split AC, split AC only internal air and then the another main thing is that they had also mentioned NABH that the windows split AC should not use in any type of operation theatre. Why? Until unless you don't think about that, why? Will not get the answer. See, the very simple reason is there. There is the cooling coil inside the split AC or cassette AC. When the cooling coil is there, water particles are coming. When the water particle is there, there is always growth of fungus on the water particle, where the fungus bacteria growth is there, where the water particle is there. And you cannot seal those, means you cannot clean or seal those pockets of the infections. That's why they said that the window splitters should not use. But what next they are given the solution that the centralized air conditioning system. In centralized air conditioning system, you are keeping the AC on the terrace. The duct is coming, supply duct is coming on the plenum or the laminar airflow, and the return ducts are on the four corners. They are taking from the four corners. They are taking the return air. Return air risers are there, and that goes to the AHU, and that type of circulation they are doing. So when you do the circulation from this type of system, you cannot clean the ducts. You cannot do the regular maintenance of the duct. And when there is no, if you are not maintaining the airflow in the duct, then what will happen? Then that duct will become a bedding ground for the bacteria fungus to grow. See, when there is the condensation, what is the condensation? On the duct's outside temperature and the inside temperature, when that temperature differences come, then on that, because of that temperature differences inside the duct, you are getting the fogging or humidity level is getting increased. So when those type of conditions are there, we'll get the because of the condensation, fungus bacteria growth will be tremendous. I had around 2 years back before COVID time, I had done the robotic duct cleaning of the Zakir Hussain. The 7 OTs are there. On the 7th floor, 7 OTs are there. When that robotic duct cleaning has been done, or the 7 OT, more than 200 kg fungus, bacteria, and the dust particle growth was there. That is clean because of that robotic duct cleaning. See, when that much layer getting on the inside the duct, and when the airflow is given from the duct, HEPA is the last terminal filter. All those dust, whatever they accumulated inside the duct, will go and deposit on HEPA filter. Okay. When that go and deposit on HEPA filters, you will initially the HEPA will get choked. Or you are getting the less flow from the HEPA. Okay. That much is okay. But when it's more accumulated on the HEPA, when the HEPA is getting completely choked, what will happen? The back pressure will develop. And that back pressure, because of that back pressure, chances of HEPA bursting is more. Because normally when we are seeing when the pipe of the water, when we are pressing on that, when we are pushing, means pressing the pipes, from the back side that pipe get removed. Why? Because the back pressure is developed, and it's increasing the flow of the water like that. Same way in the air, when you are means no flow coming from the HEPA get choked, and HEPA may get burst also, because HEPA is the paper filter. It's not the nylon filter or anything. So it's the paper filter, like a tissue paper. When the pressure comes on that, it will burst. See, normally in our system, what we have done, normally for the 400 square feet OT, they required 4,500 CFM airflow. How much is required? 4,500. We had introduced our system in that just 1,500 CFM is okay. By giving the flow of 1,500 CFM, we could maintain that much air changes, particle count, flow, everything is maintained with our system. So initially, when you talk about that see, when in the NABH guideline, what they have mentioned, that is put it over there. In NABH guideline, they have mentioned that the air supply through the from the terminal HEPA filter that is required, and our terminal minimum size of the how much filtration is required. So on table, when this is our table, both the side 1 feet, that flow has to become. So main purpose of that laminar airflow to make the air tent on the table, on the table, so that the outside air will not come on the tent, and the patient on patient body and the doctors who is operating should get the should under the HEPA filter flow. Okay, so for that this system has been mentioned, and the how much CFM is required. So in that they had mentioned how much CFM is required, how to calculate the CFM. So they said that if you can maintain the 20-year changes, that if you can maintain 20-year changes with your system, that much is required for the CFM. So by the ducted system, if you ducted system, they required 4,500 CFM to maintain the 20-year changes. My system is the ductless, no duct. So when the duct is not there, the only 1,500 CFM is okay for the system. Next. So initially we started the ductless system, and in our ductless system, you can see the I put it over there. The flow, this is the dedicated system. Okay. There is no different system is required, like the ducting and other things. So this is a single ductless system, and we have the two systems for that. Initially, we had wall-mounted AHU and the laminar airflow on the ceiling. That type of system is also there. Where you are getting the guide. See, initially we have the system where the AHU is put on the wall and the lamina is on the ceiling. In this system, the HEPA one HEPA is given on the AHU level, and another HEPA is on a laminar plenum system. So air before coming on the table, it's getting the filtered twice a time with the HEPA. Okay, so because of that, the air quality what you are getting on the table, it's 10 times better as compared to the ducted system. See, OT clean room is always considered with the class, what class you are giving in your OT. Particle count. ISO had given the class 1, class 2 up to class 7 for the air quality. See, when we say the class 1 means the particle count is between the 1 to 10 particle per square feet. If the particle count is between the 10 to 100, it comes to class 2. When particle counts goes from the 100 to 1000, it comes to class 3. Class 4 means 10,000 to 10,000, class 4. And 10,000 to 1 lakh comes under the class 5. As per the NABS guideline, they say that near the HEPA we require the class 2, means particle count up to 100, sorry. Okay. And their OT class, what they are giving is the class 5, means up to particle count is accepted up to 1 lakh. What we are giving in our system, means when we give this system, the ductless, near the HEPA we could give the class 1, means particle count is not more than 10. And on table we are giving the class 3, particle count is not more than 1000. And anywhere in the OT, if I take the particle count, it will not go more than 10,000. Okay. So our particle count, what we are giving is the 10 times better as compared to the ducted system. Now, for this system we required. For these systems, we required the two systems. One AHU has to be given on the wall, and another is on the lamina on the ceiling. Now we had developed the very advanced system. Apart from that, now we had developed the AHU which can be given directly on the ceiling, and the lamina AHU and the lamina we make the combine. We make the AHU ceiling suspended AHU come laminar airflow system. So the photo. See, this is the system where the AHU is hang from the ceiling, and in that ceiling we have the pre-filter section, HEPA filter sections. Pre-filter section where the two filters are there, which is the nylon filters, which can be washable, cleanable, and another side having the two filters where the activated carbon filter and HEPA filter is given. So HEPA filter flow directly, air conditioning and the HEPA filter both you are getting from the same system. So that's why it's called the AHU cum laminar airflow system. So the benefit of my system is that what I had given the body of that AHU, having the aluminum profile with thermal weight, ACP paneling and acoustic material has been given. So because of the ACP paneling and other things, this body will not get the lifetime rusting inside the AHU. So life of the AHU is the lifetime. See, that is the main problem with the maintenance is the main problem. And you see the ducted systems body, they are giving the GI paneling per paneling body. They are normally give. They are having the single skin, double skin body is there. Single skin means that there is only outside they are giving the GI paneling. No, nothing is inside. They have put the thermocol inside and give it. See, normally if you do AHU, all the AHU means the ducted systems AHU, life is not more than 5 years. Life is not more than 5 years. Because of the condensation and other things, they get rusted from the inside. See, in the AHU there is a cooling coil. As I told you, when the cooling coil is there, water particle will be there. And when the water particle is there, they will make the flow, means getting the spraying of the water particle on the body get rusted. Okay. The same system in a ducted system, their ducting life is not more than 4 to 5 years. See, normally in the ducted system, they are giving the 5 mm, 0.5 mm means seat they are using. 0.5 mm is very thick, means they have to bend it. They have to, for the making the duct, they cannot use more the thickness seat because they cannot give the proper shape to them. That's why. And if you compare their systems, if people say that we are not using the GI, we are using the aluminum, but aluminum is also getting the rusted when it comes in a contact with the water. Okay. In my system, as I told you, I have not used any metal. I have used the ACP paneling for that. So it will not get rusted. Okay. Second thing is that for the sound and other things, we are giving around 55 dB on table. That much less sound you will get on your table. And our body is very compact. See, normally if you compare the means AHU of our system and other system, outside this there is also one AHU and a ducting that is there. You can see their sizes. Sizes are big. Normally for the 400 square feet OT, the size of the AHU they are giving is the 6 feet by 4 feet. In my system, what we are giving, very compact, 3 feet by 4 feet. That much is the size of the AHU. So see, the 6 feet is the length and the 4 feet is the 4 feet is the width and the 6 feet is the length. That's all. Very compact, and the depth what I have given over here is just 20 inch. 20 inch means half the meter. Means quarter to 2 feet. That much. So because of this compact design, we require the less CFM. Then main thing is that the expenditures, electrical consumptions. In my system, the flow what I have given is just 200 watt. If it runs for the 5 hours, then the 1 unit electricity is required. In ducted system, they require 3 to 5 kilowatt motors is required in their system to run the show. And tonnage. In my system, in the Bombay side area, we are giving the 6 ton to 8 ton. So maximum for the cooling to get around 18 degree, 16 degree temperature, 8 ton is the maximum requirement with our system, where their AHU, their minimum requirement is 11 ton. So tonnage is also required more because the ducting that means getting the losses in a ducting cooling is get lost. So for that they require the higher tonnage. Then condensing coil and other things, what we are using. See, normally in a condensing coil, we give the per ton 7 square feet is the copper piping we are giving. As compared to the Blue Star or Dicade, what normally they are giving, for the 1 ton they are giving the 3.5 square feet copper pipe. So we had given just double to that. Why? In the summer condition, like when the outside temperature is around the 50 degree, 45 degree, their compressor doesn't work. They get heated. And in my system, one of the HU also I kept over here. You can see. We had given so many other systems apart from the compressor and the condensing coil and fan. They are giving us 3 systems. In my system, I had given the oil reservoir, means oil compressor oil arrestor is given. Then the LPHP switches is given. Then the dryer is also given to filter the AC refrigerant gases. And apart from that, how much ampere is taking, how much load coming on the compressor. To check that, we had given the ampere meter. So with that, we'll come to know what is happening with the compressors. Then we had given the 3-phase preventer has been given, so that the AC compressor will not, when the phase is changed, the normally compressor, the rotation also gets changed. So if the MSCB people had changed the phase from the outside, the compressor, instead of rotating this way, they rotate like this. So the compressor means the problems comes. In my system, when I have put it a single phase preventer, so this type of problem should not occur. And safety of the condensing coil, our system should be maintained. So all the precaution has been taken. And the body what we are using for the outdoor unit is 16 gauge. As compared to the others, their gauge around 24. So very means quality wise, you can find the many difference with that. Then in my system also I have given the UV light near the cooling coil. So on the cooling coil, I said that when the water particle is there, always chances of fungus growth is there. So we had given the cooling UV lights over there near the cooling coil. And apart from that, we had given the negative ionizer. Negative ionizer, what it do? It continuously blasting the negative ions. And when the negative ion is blasted, all the pathogens, bacteria, fungus, virus, mold, dust particles, everything is the positively charged. When they come in contact with the negative ion, they get destroyed. To show this, I had put it one jar on my stall where the smoke is coming inside, and when we put the negative ionizer, immediately within a few seconds, 10-15 seconds, everything is get disappear. So ionizer having also one of the major role, and this will also bring down the particle count in your operation theatres. Then apart from that, we had given giving the water pump to remove the water particles. What is getting deposited in a tray of the cooling coil, that is get immediately disappeared. We are using the golden and blue fins in our condensing coils. So because in a condensing coil, when you use the blue fins or the golden fins, your life of the condensing coil is getting reduced. Means life of with the blue fins and the golden fins, the life is minimum 15 years. And the thing is that once you close down system, immediately all the water particle is drained down, and no water particles can remain in the blue fins, golden fins, condensing coil, all get drained down and they dry up. So chances of getting the infection on the deposition of the fungus, bacteria, growth is not possible with this type of systems. See, main thing is that the air quality, as I told you, near the HEPA, we give the class 1, class 3 is on the table, and the class 5 anywhere in the room. While if you compare this quality, our quality is 10 times better. 10x quality difference is there. So chances of when the particle count is less, the infection, getting the infection is also, chances is also minimized. See, most advanced things that now we have developed the live monitoring of the infections. In my system, I had now developed that we are giving the display, that is optional. Whoever wants the display air quality count, if you want, we had given the display. In that you can see how much is the temperature, then humidity, how much airflow you are getting from the HEPA, then how many air changes has been maintained. 20 times air changes per hour means how many times your entire body's air get changed from the system. That also we are giving, so showing in that. And particle count, what particle count you are maintaining in your operation theatres. Then your HEPA filter is properly working or not, whether that choke or that is the burst. Everything you will come to know with our system. We are giving the differential pressure gauge for that. So just not talking, you can see the values on your display. According to that, you can find out whether your HEPA is properly working or not, whether it's choked, how much it's choked. According to that, you can take the precautionary level. See, main thing that if you make a competitive analysis of the ducted and ductless, these are the competitive analysis. As I told you, they required the 11 ton AC. Our system required 8 ton. Then the 3 to 5. Everything I had discussed. Routine cleaning is not possible in a ducted system, which is possible with our system. And see, if you see in their system, as I told you, they have to keep the AHU round the clock on. So during the non-functioning hours also, if you keeping the AHU round the clock on, your electrical consumption and the electrical bill is very high. So that is not possible. That is not a case with our system. We require the minimum electrical consumptions are there. See, I had given a calculation. When normally when we say the 1 ton AC, it means a 0.8 kilowatt. Okay, and if they required 11 tons, so 11 into 0.8 will be 8.8 kilowatt. This is per hour. 8.8 unit per hour is required in a ducted systems. And if you consider the minimum 2 hours means 12 hours, if they are keeping around 12 hours, 6 hours as I told you, the OT is operational, and rest 18 hours are non-operating time. So if you can make the calculation accordingly, in the 6 hours, if I calculate with the 8.8 kilowatts, how much is the thing? Hello? Yes. See, in the electrical consumption, if I calculate it with our system, for the per year, it's becoming 1,71,000, and with if you calculate with the ducted system, it goes to around 6,20,000. So you see the difference, around 3 times more. Okay, and annual maintenance in our system is just 25,000 per year. We take only 3% of the value of the OT, AHU. Then in their system, they have to maintain the ducts, they have to maintain the insulations. That is also getting the spoil. So their AMC charges are more. They goes minimum 7%. That is around the 75,000 to 1 lakh, depending on the OT and other things. Then they have to change their HEPA filter every 6 months. NAP says that every six monthly they have to change the filters, or they have to give the imports on that. In our system, we had given the post-stage filtration. Two filters are there, which can be routinely cleaned and washed and changed. So our HEPA filter life is minimum 2 years. Minimum 2 years is there, and our HEPA status, you can see you are getting the digital value of that. With the differential pressure case, you will come to know whether HEPA is working properly or not, which is not possible with the ducted system. They have to call the third party for the validation. They come and check the HEPA filters. They do the test, smoke test and droplet test they are doing, how much difference is there, and according to that they say that the HEPA is now working properly or not. Then, as I told you, the ducted systems require the robotic duct cleaning. In my system, that duct is not there, so no need of that type of expenses. So one time for the one-time robotic duct cleaning, they are charging around the 50,000 rupees. If they have to do the twice in a year, it comes to 1 lakh rupees. And apart from that, see that the main problem is that hospital is the commercial place, and for the keeping the AHU, they have to do the space of 10 feet by 10 feet. To make the separate rooms for the AHU, utility maintenance, they have to keep the space for that. So in my system, there is no ducting another AHU. For the keeping the AHU, no separate space is required, that is attached inside the OT only. So that type of expenses is also minimized. And see, if you calculate in a commercial place for the 10 feet by 10 feet, if I calculated 1,000 per day, then also for the 365 days, it's become a 3,65,000. That amount is that much you are losing per year. So according to that, the per year maintenance cost in our system and other system, if you see the differences, then almost the 12 lakhs rupees difference is there per year. And for the if I calculated for the next 8 years, the difference of the ducted system and the ductless system, operating maintenance cost, one is the capex, another is the opex. Our capex is also less as compared to the ducted system. Main thing that the commercial means what the purchasing cost is also as compared to the ducted system and the ductless system. Our systems almost 4 to 5 lakhs rupees is economical as compared to the ducted system. And if you say the OPEX maintenance cost, over the period of 8 years, you can find a difference of almost 1 crore 35 lakhs. So over the period of time, that system is a white elephant for you, and the expenses for that is very high as compared to our systems. See, main purpose of making the awareness about the airborne infections and other things. Now, another place where the more infection is there, that is the ICU, NICU, where you are keeping the patient is admitted. What they are using for their air quality? They are giving the cassette AC, they are using the split AC. Some people use the centralized air conditioning system also. But what's happened when you use the split AC and the cassette AC? Only internal air is getting circulated. I have admitted with one problem, another patient having another problems, third person is having another problems. When they are on one place, one room, whatever they breathe and their sneezing and other things, whatever the air quality is maintained in that area, one patient to another patient, chances of nosocomial infection is more. Hospital acquired infection is also more. So, because there is only internal air is getting circulated, no fresh air is coming inside the ICU and NICU. We have developed one more product for that. Your existing ICU, NICU will get the air changes with our new system, which will cost just 1.5 lakhs. By spending the 1.5 lakhs, you can convert your ICU, NICU into the place where air changes and the air positive pressure getting inside through the HEPA is possible. In that system also we are giving the post-test filtration. 2 pre-filters are there. One for taking the pressure from the outside, one from the internal air circulation, and 2 other filters. One is the activated carbon filter and the HEPA filters. So any any existing ICU, NICU can be converted to the modular, where the facet and the air changes is maintained, that is just with 1.5 lakhs. And existing OT, the people have said that we had already installed our systems and the modular OTs are working, and we have all the problems. How to convert our OT into the modular OT, the ductless OT. That is also possible. Now we have developed the ceiling suspended AHU. In that, you don't have to do any changes in your paneling, flooring. Just by changing the ductless AHU come laminar, you can convert your any OT to the ductless air handling OT, laminar airflow OT within a day, and that too with a minimum cost. 3 ton AC for that OT like gynac OT, opthal OT, that can be made with the spending of just 2.5 lakhs to 3 lakhs rupees. Very minimum. See, actually the problem in the gynac, we are saying that the gynac OT is the unhygienic OT. We are not looking in that aspect that the patient who is coming for the delivery is also human being, and getting the infection to the lady is much more in a place like a labor ward. They are not keeping any air quality over there. They are not maintaining any hygiene over there. And the saying the unhygienic OT, they are means insulting to the ladies, means our so that we have to keep, we have to take care of those ladies also, and the person means the baby who is coming to the world, he should be also he should not get infected, and we have to, it's our duty to give the healthy environment to them. Okay. So whatever the care we are doing for the other things, I believe one has to do something for the gynac OTs also, and the labor rooms also. And spending the 2.5 lakhs rupees is not a very big amount, because nowadays for the cesarean section and other things, the doctors are charging more than 60,000-70,000 rupees per delivery. So this amount what we are asking for the making the hygienic and environment friendly system is just hardly some amount is there. So thanks for giving the time and attention. If any question regarding any product, please you will get the proper answer. Any query about any doubts about the system, whatever the queries you have.
Do we need to make any changes as per the OT sizes? If we are working on ortho OT, we are working on labor room, we are working on general surgery OT. So the sizes may be different.
Different.
So
tonnage calculation is always according to the size of the OT.
So
see,
what you mentioned is 4x3 is your paneling on ceiling.
The AHU size will be the same.
That will be same.
That will be the same.
And
See,
for HEPA paneling, so that window we need to create, right?
see now we have the two systems. As I told you, we have the two systems. One system which can be given AHU on the wall and the laminar on the ceiling. Okay, that is the system what we suggest mainly for the ortho OT or the NAPO OT, where the sizes of the OT is big, and that they have to use the C-arm and movements required. So normally for those type of OT, the area is bigger. They go for the 400 square feet OT. We suggest if you take that type system, where the tonnage maximum what we can give is the 6 to 8 tons. See, I am not means recommending ceiling suspended AHU, which having the more tonnage. Okay. See, because normally in the ducted systems, the peoples are giving the 11 ton AC. Just consider, just feel 11 ton AC is the flow directly coming on the patient body. Patient also is lying on the bed without any cloths and other things, and the 11 ton AC direct flows coming on the patient body. So he is complaining for the sewing. The sewing complaints are there, and getting the hypothermia chances is more with the if you give the more tonnage on directly on the patient body. So we recommend up to 5 tons, we can give the ceiling suspended HU. Above that, we say that go for the double system. That is much better for the patient and the doctors to operate. See, if you take the double the system, the channel means the airflow coming on the body is a double filtered with one HEPA is the, we are giving on the HU level, another HEPA we are given the laminar level. So twice a time getting the filtered with the HEPA. Any other things? Any other doubt?
Sir, you said that as per norms we require 20 AC page.
Huh?
20 AC page as per norms.
Uh-huh.
Okay, in ducted system you said that for one example you have given that 4500 CFM required, in your system is required 1500.
Yes.
So how you maintain that 20 AC page in that
Yes.
less CFM?
Now, right. See now the giving the CFM is calculated how? I will give the formula how to calculate the CFM. Okay. You have to calculate how much flow is coming from your HEPA. That is it's calculated in FPM, feet per minute. Okay. Then you have to calculate what is the size of the HEPA. If the size of the HEPA is say the 2 feet by 2 feet, 4 square feet, then whatever the flow is coming, you have to multiply by that. That is called the CFM. Okay. Simple formula, just to understand that. See now, in a ducted system, you are keeping the AHU on the terrace. From the duct, you are taking the flow to the plenum level. Government means NABH had made some guideline also for that. How much flow you can derive from the laminar. Nowadays, earlier the people are giving the 90 to 120 FPM flow. Now government NABH has further reduced that up to 25 to 35 FPM flow. See why they are giving that much less flow, and how they can means if you calculate the 20 air changes, see for the 20 air changes, the losses is there in between the duct. In my system, the HU is directly putting on the ceiling or one of the wall of the wood HU. So we don't require that. Losses is not that much. And one formula is that you have to take the length, width and height. That is the volume. For that much volume, if you, whatever the CFM you are giving, if you divide with that, see for example, length is 20 by 20 by 10. Okay, 20 by 20 by 10. So how much it will be? How much it will be the area?
400 and 400 area. 4000.
20 by 20, 4000. Okay. What you have to do? Whatever you are taking the CFM of that AHU, you have to CFM into 60. 60 for calculating for the 1 hour, and just divide with that volume of your air. You are just divide with the 4000. What is the home volume? You will get the how many air changes you are maintaining in that. See, in my system, because there is a ducting is not there, by giving the just 1500 CFM, that much air changes is maintained. Got the idea? Any doubt about after that?
And what about positive pressure?
Positive pressure, right? See, for the taking the positive pressure, how it means you will get the positive pressure, you have to add the fresh air. Okay. See, in my system also we are taking the fresh air, we are giving the fresh air dampers we are given. In the ducted system, they also take the dampers. With the damper, they are taking the fresh air inside. There is one filter is there. It's called the pre-filter. I told you that there are the two filters. One which is taking the internal air circulation, we are given one, and the one which is taking the fresh air from the outside. These two filters has to be cleaned. So in my system also, the positive pressure, we are taking the positive fresh air from the outside, so you will get the positively pressurized. And one more thing I had done. See, normally there is a fresh air damper is there. There I had put it one fan, and that fan can be on when the AHU is not working. That time also we can keep that fan on, and with that small fan on, you will get the positive pressure always when there is the no OT working, no AHU. We are not keeping AHU on for that. That is also possible with our system, and we are given that. to keep the positive pressure in the room, what I use the fan is a very small fan of the 12 volt at the computer fan. With that much small fan, your OT will get the positive pressure. As per the NAPS, how much positive pressure is required is just 2.5 Pascal. That much less positive pressure is required, and that can be achieved with a very nominal increasing the flow in the positive pressure. You don't have to require lot of air changes and other things when it's not working. Non-working hours, you don't have to require the 20 air changes. That time, if even by taking the positive pressure, if the one air changes is also there, your OT is positively pressurized. Okay. Any other things, sir? See, you make a question for any problems you are associated with the OT. I will give the solution for that. You name any problems related to the air quality problems. See, now in the COVID times also, now again in Mumbai that COVID is got started. Government had started the COVID. What's also again. So the thing is that COVID, in the COVID time also, to save the to the doctor and staff should not get the infection. That for that I had developed the positive pressure system, negative pressure system. From the one side we had given the positive pressure system. So whatever the air is coming inside the room, ward, is through the HEPA filters, and another side on the bedside of the patient we had put at the negative pressure system, where whatever the infected air will go out, and before the going out there is the P-filter, HEPA filter section, and apart from that we had given the virus burning unit in that. Means the air is passing through the 80-85 degree. So the spreading of the infection in the surrounding area is not there. And you are getting the one-way ventilation. So swiping out the air is always there. Infection from the COVID ward. See, anywhere if you find any type of room or any type of area where you want the air quality, means where the chances of infection is minimum, that is possible with our system. Okay, sir. Thank you. Thanks a lot for that.
I would like to thank you on our honorable guest speakers, Mr. Zakir Hussain, for this wonderful section. I hope it will be great help for all the attendants. I also would like to thank all the attendants for the beginning here. Thank you all of them.